All right, welcome to part 2, starting up where we left off. Oops. Here we go. We've got a sub 31 equals a sub 1, we don't know that, times 7 times times 31 minus 1. Good? Okay, so how does that help us? Well, we still have a sub 1 here. We have a sub 1 here, so watch what we can do. We can take this and substitute that in right here where a sub 31 is. Now look what we have. We have 1085 equals 31 over 2 times a sub 1 plus another a sub 1 plus 7 times 30. Good? 1085 equals 31 over 2 times 2a sub 1 plus, what's 7 times 30? Oh, sorry, I don't know why I put a 7. The common difference in this problem is a 1. Let me change that. Okay, so we'll just say plus 30. Good. Now inverse, how do we get rid of this? Well, let's multiply by inverses. I'm going to multiply by 2 over 31. Multiply this side by 2 over 31. Okay. So this is going to cancel. This is going to cancel. So now I have, let me make this a little more clear. 2 over 31 times 1085 equals 2a sub 1 plus 30. Let's subtract 30 from both sides. Equals, sorry, let me put minus 30. Okay. Equals 2a. And if I'm correct, if you plug this into a calculator, this should become 40 equals 2a sub 1. And divide both sides by 2, you end up with 20 equals a sub 1. Okay. So the first day, he started with 20 push-ups. Okay. This is our equation for a sequence from yesterday. This is our new equation. Take a look at this. This is a third equation. I don't personally use this equation. If it helps you, then you should use it. Okay? How we get this equation is if you take this and you substitute it into here, right where a sub n is. Then you get this. S sub n equals n over 2 plus 2 a sub 1s plus d times n minus 1 from over here. Okay? Find the first 3 terms of an arithmetic sequence. Okay, here's what we want. I'm going to put it at the very bottom. We're looking for the first 3 terms in which a sub 1 equals negative 16, a sub n equals 33, s sub n equals 68. What do we not know? We don't know the difference, and we don't know n. We don't know how many terms there are here. Okay. To find the first 3 terms, well, the first one we know. We can just write negative 16 in right there. How are we going to find 2 and 3? What do we need to know? We definitely need to know the common difference. That's what we're looking for. Let's write these equations out. S sub n, I'm just going to, it's already written above, so we'll just use it. I'm going to use this equation right here. Okay? So we're going to say 68, that's my S sub n, equals n, I don't know n, over 2, times a sub 1, I know that, plus a sub n, I know that. Good? Okay. I do with that? I could solve for n, but that's not really what I'm looking for. So let's try another equation. Let's try this one. A lot of arrows going around here, huh? There we go. Let's try this equation. I've got a sub n, well, that's 33, is equal to a sub 1, negative 16, plus the common difference, that's what I'm looking for, times n minus 1. Oh, well, I can't really use this equation until I get rid of the n. So look, if I solve for n, let's do that. 68 equals n over 2 times what's negative 16 plus 33. That should be 17, I believe. Okay. Now let's multiply both sides by 2. And let's divide both sides by 17. Okay. That's going to help us solve for n. So let's plug this into a calculator. N is equal to, let's see if I can get it here. N is equal to 68 times 2 divided by 17, 8. Okay? Now if n equals 8, we can rewrite this as 33 equals negative 16 plus 8. Sorry, that's plus d times 8 minus 1. There it is. Now just solve for d. Okay, let's add 16 to both sides. That becomes 33 plus 16 equals d times 7, right? 7d. So let's divide both sides by 7. That cancels. This is what d is. Let's find out what it is. 33 plus 16 divided by 7. D equals 7. Okay? So now let's use that. 16 plus 7 is negative 9, plus 7 is negative 2. Next problem. Okay, look at this sign. That's a sigma, and how it's read is this. It's the sum of 3n as n goes from 1 to 10. This is a series, and this is what it looks like. First, take n equals 1 and plug it in here. That's 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus, do you get the pattern? I'm going to keep doing it because there's something I want to show you at the end. 3 times 7 plus, oh, I'm running out of room, plus 3 times 9 plus 3 times 10. How many terms do I have altogether? I've got 10 terms. Look how you get that. 10. Where does the 10 come from? Okay. I'm going to give you another example down here because it's really important to be able to figure out how many terms you have. So let's talk about this one. We're going to evaluate this. First, I'm going to write out the entire series. Plug 2 in for k. So the first term is going to be 5. The second term is going to plug 3 in. It's going to be 7. Next term is 9. Next term is 11. Last term is 13. Okay. What's a sub 1? Well, I'm not even going to do that yet. What I really wanted to point out is, what is n? How many terms do we have? We have 5 terms. How could you figure that out without writing it all out? N is found by taking the top number minus the bottom number plus 1. Okay? The reason why we add 1 is because you have one term for each number. So it's, if you did just 6 minus 2, you would get 4, but you have to include the first one as well. Okay? So it's 1 more than you would get just from subtraction. All right, so let's keep going here. You do not need to figure out all of these. That was just to show you what's going on. Okay. What is a sub 1? Well, a sub 1, we plug in 2, that's 5. What is a sub 5? What's the last term? I'll plug in 6, 13. Good? Do you need to know the common difference? I don't know, let's see. What is it we're looking for? We're looking for the sum. And this is what we're looking for. So let's write it. S sub n is going to be equal to n over 2 times a sub 1 plus a sub 5. Did you get it? We don't even need to do the common difference this time. Just evaluate this in your calculator. And we're finished. What did you learn today? What is the difference between an arithmetic sequence and series? One has commas, one has plus signs. Think of a real-life situation which can be modeled as an arithmetic series. And just so you know, here are the answers for last night's homework.